following sets of measurements of two variables, x and y, were obtained from an experiment. It's thought they are related by the formula y is equal to a, b, x. By converting this data set to linear form, determine whether the relationship is true for these values. So we've got x is 1.5, 2.8, 3, 4.2, 5 and 6.5. We've got y is 80, 35, 33, 18, 10 and 6. Right, first what we're going to do, we're going to plot these points using software called GeoGebra, and we're going to use the fit growth command, which is y is equal to ab to the x. This is the one we're going to actually use, but you could use fit exp, which gives you a graph of y is equal to ae to the bx command. We're going to use this one because that's what was required by the question. So I'm going to show you how to do that. So what you need to do is open up a GeoGebra file, okay, and here you have the algebra view, graphics view and the spreadsheet view. I have already prepared the axis for this question, so you can have prepared the axis for yourself, okay, and I've entered the data, so all the x values are here and the y values are here. So this is what you do. You take your mouse and you highlight these values, then right click and then you go to create, and you need to create a list of points. Okay, if you want to get rid of the labels, click on if you want to get rid of the labels, if you select all the data and right click and go to take off show label, and if you wanted to, if you select all, press shift at the same time, right click object properties, and you could change the color if you want. This is all down to personal taste. And change the color of the points. Okay, with them, deselect them and then go down here to input, which is right down the bottom here in this version, and write down fit. When you press fit, a load of commands come up, and we want you see fit exp, we want to do fixed growth as I just said, and because I now have a list of points, it's now called L1, so you need to enter capital L underscore, that does the subscript 1, and you see that will come up with our function. If I slide that across, that will come up with my function. If I go to view, I can change the number of decimal places if I want. Now I've got one that I've already sort of prepared already, so this is this one here. Don't worry about all the other numbers down here, these will appear later. So here is my function. I've got it set to in options rounding. I've got it set to 3 decimal places. Okay, so I've got that y is equal to 160.6 times 0.592, and we can see that we've got a fairly good fit. So if we go back to this for a minute. So here's my graph. Okay, these are the points I plotted. This is what I was trying to fit it to. Y is equal to a times b to the x, which is 160.6 times 0.5692 to the power of x. We can see that how well the data fits, and it does actually fit quite well. It's quite a good fit to the data. Right, now what did we do in the days when perhaps we didn't have sort of graphing softwares? Then it is possible to use a different method. So the method is called to convert the data to linear form. So there is my data, and we said y was equal to ab to the x. Now if we take logarithms of both sides, we could take log to the base 10, but you can take any base if you wanted. Let's take log to the base 10 of y is equal to log to the base 10 of ab to the x. Right, if we now use a couple of rules of logarithms, so the first rule we're going to use is log a b a x y, so a will be a and y would be b to the x. It's log a to the x, log a to the y. So x would be b, and x would be a, and y would be b to the x. We're going to use this one in a minute. We'll come back to that. We get log to the base 10 of y is equal to log to the base a of x plus log to the base a base 10 of b to the power of x. Now if we now apply this bit to this bit here, the whole thing becomes log y is equal to log a plus x log b. So if I just swap these two over, we got log y of x log b plus log a. This is called a linear form. We'll convert this data to a linear form, but what you have to do is plot x against log y. So you take the x value and now put it log y. So you now take log y of 80, 35, 33, 18, 10 and 9. So we're going back to our GeoGebra file. If we copy these, so that's Control C and just put them in C here, Control V, and then do log, and then we have to say the base, so 10 comma B1, that gives me that, and if we slide down there we get all the values. So you have to put the base log 10 comma B1, so that will consider that value there, and then if you paste downward like you normally would do in Excel, you get all these values here. Right, I'm going to close the graphics view up, so just close that up, okay, and then I'm going to go to view, and then I'm going to bring up a graphics 2. Okay, graphics 2 I have prepared already, and notice the label, the axes are x and log y. So all it is a graphics 1 value, but another window to work in. Okay, and what I'm going to do now is I'm going to select these points here. So this will be x against log y, and if I right click and I create a new list of points, I get a new list of points, and we actually see that they roughly run in a straight line. Again, if I click that and click there and press Shift and right click, get rid of the labels because we don't really need those, and if I wanted to change the points to a red one. Okay, now if I could actually get the software as well to do a fit. Now I want to fit line because I want to fit a straight line to this. Now obviously in an exam you'd have to do this by fit, and now because my list of points is L2, so it's L underscore 2, I get the line, and if I press enter I get the equation. Right, so we've got the equation y is equal to, but we've got to remember it's log y is equal to, okay, it's log y is equal to, because this is what this axis was. Sorry, I lost my line, so I'll put it back again, and this is my equation, so it's log y. Now, like before, I've actually prepared one before. So going back to the one I prepared before, so just get rid of this one and go into view graphics 2. Okay, so this is my graphics 2 one. So this is the one I prepared before. Okay, so I got the software to do that. Now, however, so if I now plot x against log y, what I get is this graph. Okay, so this is one I prepared before. It seems a fairly good fit. I'd have to draw the line with best fit. So my linear form, so use fit line for that one, but my linear form is x log b plus log a. If I compare that to y is equal to mx plus c, so m would have to be the gradient, log b, and c would have to be log a, the y-intercept. So the y-intercept was 2.2. So that means that log a is 2.2. For the gradient, I need to take 2 points. So I've taken these two here. and work out the gradient. So that is 7 minus 3. 7 minus 3, which is 4. And this one is going to be 0.6 minus 1.52, which gives me minus 0.92. Don't forget I've got a negative gradient here. So the gradient will be minus 0.92 divided by 4, which will give me a value, log b has to be equal to minus 0.23. So log a is 2.2. Now if we lose the idea that log a of b to c is it gives b to equal to a to the c, don't confuse the a's here, they're actually different. The base is 10, so this will be 10 to the power of 2.2. A will be equal to this here, 10.2.2. Therefore, A will be equal to, if I write that on my calculator, 158 to 3 significant figures. And if I do log B is equal to minus 0.23, which is the gradient. Log B was the gradient. And then again, applying this idea here, this time B will be 10 to the minus 0.23. On my calculator, that will give me 0.589 to 3 significant figures. Well, we got y is equal to, the model was y is equal to ab to the x. So I'm using my values that I've calculated. Obviously, I'll get 1.58 times 0.589 to the power of x, compared with the value that we got using GeoGebra, which is 160.6 times 0.592 to the x. It's quite a good comparison. Okay, and the data does actually fit this model, y is equal to ab to the x, quite well. So we should just add that to our answer. Okay, so this has been a video to show you how to do converting to linear form. What I will do is put the GeoGebra applet into the finished GeoGebra applet into the notes of the video. I hope you've understood, and I thank you very much for watching.